Hi, everyone. My name is Michelle Gutzait, and I'm a Microsoft Data Platform MVP. I work at EPAM, which is a world-class enterprise software development company. And today I would like to talk about how to set up Data Lake and Azure Synapse Analytics within minutes and start analyzing your data immediately. So this is a basic presentation for experienced database professionals. Because it's a basic presentation, if you are experienced with Azure Data Lake, Azure Data Factory, and Synapse Analytics, this presentation may not be for you. The goal of this presentation is to show you how to really start moving your data to the data lake and analyzing your data right away. I am going to be here with you in the chat, so if you have any questions or comments, please feel free to let me know and I will answer them in real time. Let's get started. So who this presentation is for? So this presentation is for anyone in IT that would like to know how to start with Data Lake and Synapse Analytics. You need at least basic knowledge of Transact SQL for the demos and a basic knowledge of database design. In the agenda today, I'm going to talk about your potential current architecture. I'm going to define some of the goals that you may have in order to move to that type of architecture on Azure. I'm going to talk about the full data platform architecture on Azure that the Data Lake and Synapse Analytics are part of. And I will talk about what else can you do once you set up that environment on Azure. I'm going to talk about the reasons why we should use the data lake with the Synapse and serverless. I'm also going to include some demos where you can just take your demos and based on them, start doing the same thing in your environment and start analyzing the data and using the data right away. I'm going to talk about the queries and performance with Synapse serverless. And I'm going to touch a little bit about the pricing. So let's talk about the potential current architecture. If you are not yet on Azure, if you're not yet using the data lake and Synapse, or maybe yes, but let's talk about how we used to do things before. So you may have some data sources potentially on-prem, such as SQL Server, Oracle, data sources. Maybe you have files, you have Excel files, maybe you have SAP, or maybe you are using third-party clouds like Salesforce. So you have data everywhere. You have a lot of systems and a lot of data being accumulated in different data sources. So what can we do with this data? Potentially, you already have what is called a data warehouse, where you would like to analyze the data from multiple systems, or you are already analyzing data this way, either for reporting or for analysis. So the data warehouse could be a tool or a database, could be like a cube or any specific tool that allows you to import data and analyze the data for reporting or analysis. And in order to move data into that data warehouse, you probably have some ETLs or ELTs in place where you're moving the data, transforming the data, summarizing the data, and making sure that you are bringing the data in a specific model that can be used for your reporting or analysis. So you probably are using some ETLs tools, such as the Microsoft SSIS or any other third-party tool that is an ETL or an ELT tool. And then once you have that data warehouse, you can actually, the users can use any tools, either reporting tools or any analysis tools, to review this data and do reporting and analysis. So let's talk about how the data lake and Synapse serverless can help improve this type of environment. So first, let's talk about what would be the common goals that we would like to achieve. For sure, we would like to achieve in many cases, we would like to get fast reporting environment, potentially close to real-time data. or maybe even real-time data. We wouldn't like to affect the performance of the source systems by doing reporting and analytics, because we would like to keep the source systems for online transaction processing and operational systems. Maybe we would like to keep the business models separately from the physical models. So when we're talking about the physical models, you have a bunch of tables. Maybe the table name and the column names are not as expected by the business. So just to give you a very simple example, let's say that you have a third-party tool that is calling a customer, and another third-party tool or in-house development where you call the customer a client. And from the business perspective, you would like to call this a prospect. So you don't want the business users to see actually the physical model. You want them to see the data with the names that they would expect to see. For example, prospects instead of clients and customers. You can use the data warehouse, or what we will see on the data lake, as a one source of the truth. What does this mean? Let's say that you have the same type of data in multiple source systems. Let's talk about a very simple example like countries or cities. In one system, the list is going to be up to date, and in another system is not. So we would like to make sure that we have one environment where we have the up-to-date data. Potentially, it could be data that is being queried or copied from multiple systems and being transformed in a way that it's a clean data and it's the real source of the truth that we can rely on. We may want to have an environment where the business users can actually, without any difficulties, review the data and play with the data, maybe with some simple joins, because they need to understand what type of data they can get reporting or analytics from, and then based on those like inquiries that they're doing, they can then send requests to the development teams to create specific reports that are good for the business. Sometimes you are accumulating a lot of data in the operational databases, and we want the operational databases, because performance usually is very important. We would like to try and keep the operational databases as small as possible. So you can use the data lake or any data warehouse to keep also the history of the data itself, so that the OLTP database is going to be as small as possible. You are going to purge the data and archive the data somewhere, or keep the historical data somewhere that is still accessible. So in some occasions, you may want to purge and delete data from the OLTP environments, but in other cases, you would like to keep data just in case. But you don't want this to be very costly. Maybe you have tons and tons of data, so you would like to keep data in a way that it's still accessible, but it's not very expensive to keep it there. Maybe you would like to also keep summaries of the data and not necessarily the raw data. So you want somewhere where you can transform the data in a way that is going to be proper for your reporting and analytics. Maybe your OLTP environment, your operational environment, does not need the data summarized that way, but you need a place where it could be summarized for other needs. Sometimes you would like to keep the versioning of a row. So to give you an example, if you have a financial system operational where it is a third party, and let's say that because it's very old, the data is being updated. So each row, when let's say prices change, the operational system updates the same row and does not keep the previous one. Sometimes for financial systems, it's very important to understand what was the value before the change. So you can use, this is just an example, but you can use raw versioning in that data warehouse, meaning that instead of updating the data, you're keeping the data before and you're just inserting new data. So again, you have an environment where you can have a functionality that does not exist in the operational systems, And in this environment, you can query or you can do reporting or analytics in a different way. And those are some of the examples from my experience. You may have additional examples from your experience. And so let's go and see what we're talking about. Before I'm going to go into the demo, let's talk about the data platform architecture on Azure. So this is the diagram provided by Microsoft of the entire stack of Azure. And why am I showing it here? It's because when we move the data into Azure, let's say we move the data into the data lake and we analyze with Synapse, which is this part, we also have additional services on Azure that we can use to enhance our environment. So even if we're starting with the data lake and Synapse, we may eventually need to use other services that exist on Azure. So for example, let's say that initially you were just moving data let's say on a daily basis, and then you realize that there is some data that you would need to ingest in real time. You have this ability. You have this ability to do the same thing and move the data, copy the data into the Azure data lake, and then analyze with Synapse. In Synapse, I'm going to talk about Synapse, but in Synapse, you have a serverless and you have other options that are a little bit more expensive, but provide you more functionality. Other things that we can do is there are other services like Purview that allows you to see how the data is transformed from the source to the destination. You also have on Azure, you can push data into Power BI Premium and analyze the data either using reports that are pre-created or create reports on the fly. You could also leverage Cosmos DB, which is a NoSQL database and distributed, and others. So once you're on Azure, you can actually use your setup and add some additional functionality and use other services. So before we go to the actual demo. This is the modern concept of how to create, how to move data into the data lake. Now, you don't have to follow this architecture. This is just a suggestion, but it really helps you when you want to go back and see what were the transformations of a piece of data. So in this architecture, we have this data sources that could be any RDBMS database, any files, and it could also be streaming data. And what we say is that we have at least 3 layers in the data lake. The first layer, which is the bronze or raw, which is the where we put the raw data as it comes from the data source. So imagine that you have few systems. In one system, you have clients. In another system, you have the customers. So everything will land into the bronze layer. From the bronze layer, it's easy to track back the data to the source. The next layer, because we're just dumping the raw data, we need to do some kind of a validation of the data. So let's take the example of the customer and the client. We need to make sure that here we understand which client and which customer. If, for example, if it's the same client in different systems, it will get one row eventually. So we need to go into some kind of a validation. So in one system, it's going to be client ID that could be different from customer ID. And eventually we will have to create one piece of information regarding that specific client based on names, based on something that is similar between those specific rows. And here we also make sure that if there are components from, let's say, different source tables, we need to make sure that the foreign keys, the logical foreign keys, are being maintained. So we clean the data. So we have a process, an ETL, that will clean the data and either validate the data, so place valid data in the next layer, which is the validated and clean zone, or well, you can even have an area where you have the data that has been rejected by the process. For example, rows that don't have foreign keys or values that don't make sense, and you can reject them. And then you can have a process or even human intervention to review that data and decide what to do with this, potentially going back to the cleaning processes and modifying them accordingly. So that's the silver layer. The next layer is going to be of consumption zone, which is the data models that are going to be the sources for your reports and data analysis. So in the gold layer, potentially you will see the business terminology rather than the physical terminology that you have in your sources. And then you can have another layer where you push the data into reporting environments such as Power BI for the analysis. So this is just a suggestion. And if you use Purview on Azure and you use this methodology, you can actually trace the data components and what happens to them uh, in those layers. So you can understand a source column, what happens to it as it goes through those layers. Also, on the data lake, you can store the data in different layers to get different pricing models. So you can have a hot data lake, a hot layer, which means that it needs better performance and you're actually querying it often. But you can also have a cold layer, which means that this data is rarely being queried. Or you can have an archive one that you only querying it when you need. So performance is not really important as long as the data exists. So this is just an explanation of the methodology that we're using for data lake and the modern data warehouses. Let's talk about the what we're going to talk about today. So you have your data, your on-prem external or on-prem and external sources. So those sources can be anywhere. It could be on-prem or it could be any external cloud or even on Azure. Okay, so you may have online processing environment, you may have applications and files, you may have different databases or even batch data. And then on Azure, you may also have some online processing source systems. And then we're using the Azure Data Factory to ingest the data and store the data on the Azure Data Lake storage or a database. It could be also a database. And we can also use the Delta Lake to allow for transactions over the Azure Data Lake storage. I'm not going to cover this topic, but there is a way to still maintain some kind of a transactional system, even with files in the data lake. And then the next layer would be analyze. So you can use Synapse Analytics to analyze either a database or Azure Data Lake. Or you can even push, if you want to analyze, you can even push the data into a database or another layer in Azure Synapse that I'm going to talk about. So, but basically you can analyze the data with Synapse from the store. And this is what we're going to see today. And the next layer would be to push the data into Power BI, if this is what you need, for the reporting and analytics. But today, we're going to focus only on a part of it. So as I said before, another layer that you could have added to this architecture is the streaming data. And you can stream data directly into the data lake or the database that in the store layer. And to end with this, you can see with Purview, you can see the transformation that you have, the lineage of the data from the source and how it is transformed across those layers. So it's very easy to review what happens to the source and in each one of those layers with Purview. So our focus today is going to be copying data from the OLTP systems, either on-prem or external on external clouds. Could be, let's say, any other cloud provider, either public or private, or on Azure. We're going to use Data Factory to store data in the data lake in files, and then point Synapse Analytics serverless to those files and start analyzing those immediately with SQL. So let's talk about this architecture. So the data lake, imagine the data lake as a file structure. So the data lake has the component of container. And then under the container, we have different folders. So it could be folders. So the folder here, so the container would be, for example, the raw or the silver. The folder will be the table. So for example, customer, orders, products. And under the folders, you have multiple files that can have those formats and include the actual data. So if this is the customer folder, the files underneath are going to have the structure of a customer table with the information itself. Okay, so we were talking about files. So those are the formats that can be created on Azure Data Lake. So Avro, binary, even JSON, Excel, and the one that we are going to use is Parquet files. So the Parquet files include the schema as well, and they're very well compressed. And so if we want to partition the data, I'm not going to talk about partitioning, but this is a more advanced topic. But when we are partitioning the data, so basically each of those files have specific partition, let's say by date, and we want this mechanism to work fast, we're going to use Parquet files. But for this example, we're going to use Parquet files as well so that you can see how to do that. But I could have also used, let's say, CSV files for this. It would give you the same result. Parquet files, because it's also compressed, it's known to be faster in terms when you analyze the data. So that's a recommended format. Why would you use the Azure Data Lake storage? It's very cheap. I'm going to show you when we're going to talk about the prices. It's very cheap. It's fast to configure and create. It's an Azure service that you create right away. It's very easy to maintain. We're going to see during the demo. It's easy to navigate between and see what's been created and also the contents of the files. It can be used right away. So once the data is in the data lake, you can start pointing Synapse Analytics or even other tools directly to the data lake and just view the data right away. It has a very satisfying performance. And why am I saying satisfying performance? Because it really depends on your implementation. So I'm going to talk about Azure Synapse, and you will see that we have additional stuff that we can do, not only serverless, but even with serverless, we're pointing the serverless to the files themselves, and we can do queries. So just to give you an example, I had a client that had reports that were running for 15 or 20 minutes with SQL Server, and the same SQL was running for 39 seconds on the data lake in Azure Synapse. So get this, take this satisfying performance with a grain of salt, and you will have to do proof of concept in your environment to make sure that that you're getting the performance that you need to get. And like I said before, this is well integrated with other Azure services such as Purview. So what are we going to see in this demo? In this demo, I'm going to show you, I have a SQL Server, and I'm going to use the Azure Data Factory to copy the data into the data lake, into the raw container, into the customer folder, and the file that is being generated from the customer table is going to be in customer data Parquet. So it's going to be a Parquet file under the customer folder. So again, moving data, copying data with Data Azure Factory to the data lake and creating a file in the right directory. So let's start with the demo, SQL Server, ADF, and data lake. So for our demo, I have created an Azure SQL database named AdventureWorks 2019 that has multiple tables. So if you want to connect to it, you open it, you copy the server name, and then you can open SQL Server, SSMS, and you can just connect to it. So what you do is connect, you paste, and you connect. Okay, so this is the database. I already have it open. This is the one. So in AdventureWorks 2019 database, I have a few tables. I have customer, I have orders, and I have others. So if we do a right click and select top rows, you will see that I have customer 1, and then customer number 1, customer 2, customer number 2, etc. So our goal right now is to copy this information into the data lake. So this is the database, and now let's go see the data lake itself. So this is a data lake that I've created. Generation 2, it's important to get the benefits of the Azure Data Lake Generation 2. And the way it works is like I showed before, we have containers. As you can see, I already have 2 of the containers. So I have the raw and the silver. And if I open the raw, you can see that I have folders for each one of the tables that I wanted to copy. So for example, I already copied the address. You see, we have a Parquet file under the address folder. And then we have orders under the order. So we have Parquet files. I'm going to play with this later. And then under the customer, I have nothing. So I would like to now to copy my customer data into the data lake. So for that, what I need to do, I'm opening the Azure Data Factory. And in order to do things in Azure Data Factory, I have to open this studio, the Azure Data Factory Studio. And then the simplest way to copy data is to use ingest, just to copy. So this is a UI that helps us to copy in a very simple way contents of a table. And we're going to, for now, run it once. So I'm going to click next. So what is our source data? Our source data is a SQL database. So I already have this created for the SQL Server that you've seen. But if I wanted, I could create a new connection and then choose. So as you can see, I have different data sources. One of them is RDS. If I wanted to do SQL Server, I would find my Azure database here. That could be either SQL Server on-prem or instance or Azure SQL database. Okay. And I wanted you to see how many potential data sources we have. So it could be anything on Amazon. Amazon S3 buckets. It could be Cosmos DB. It could be another blob storage. It could be many, many data sources. We have Salesforce. We have Cassandra. We have many, many different data sources from which we can actually retrieve data. But in our case, we're going to do a SQL Server. So when you want to know how, so the way I connected to the SQL Server via the SSMS, it's the same way that you're going to do it here. So I'm going to close this because we already have a connection. So here, this is AdventureWorks. Now, sometimes you will see this not enabled. So when you see this not enabled, this is an agent that helps us connect to data sources. And if it's not enabled, you just go here, you edit, and you enable it. And then it takes something like 30 seconds to be enabled. Okay, so we just enable and apply. In our case, this is already enabled. So it connected to the data source, and then you can see the tables. So let's choose the customer table, and I will do next. Now, the best practices, as you can see here, I could have chosen multiple tables, but the best practice implies that it's better to do this, to do one pipeline, one ADF pipeline per table. And this is what I'm doing right now. This is better for maintainability. So I have the customer data here. I can preview the data. So if I preview the data, you will see the same information that we've seen from SSMS, customer 1, customer number 1, and so forth. So this is okay. Let's close this. This is exactly the data that I was expecting to see, and I click next. Then my destination is the blob. Okay, so I already have this blob, this Azure Data Lake storage configured, but if I wanted, I could create a new one. So if I click Data Lake, I would have chosen the generation 2. Then I would use a count key, and then I would be able to select the one that I have to. So this is my data lake, and then I can create new. I will test the connection, but I will not create another one because I already have one. So you see the connection was successful. So let's use the one, let's discard these changes, and let's use the one that I already have, which is the Azure Data Lake storage that you've seen before. And let's do browse. So when I browse, as you can see, I can see the raw and the silver. So let's choose the raw. And let's choose, obviously, the customer folder. Now, if I did not have the customer folder, I would have to go back to the data lake here, go to the data lake, choose the container, the raw, and then add a directory. So let's add the test directory here and save. So when I go back and I do cancel and I browse, you will see my test directory as well. So I'm going to go to the customer. I'm choosing the customer folder, and then I'm going to choose a file name. Now here we can have a function with, for example, the date as a parameter, but this is more advanced. So I'm just going to call this customer 2022.parquet. And I'm going to leave everything else as default. This is a small file, so I don't need to take care of concurrent connections or block size. So I'm just going to click next. So the file format is going to be Parquet and Snappy. And again, I don't care about the max rows per file or anything else, and I'm going to click next. So my task name, I could leave it at default, but let's put something more understandable. So customer, and I can describe here. And I don't need any consistency verifications because I'm just copying the data as is. If I want, I can add logging or not. And there are other things that I could enable. Okay, if you click here, you will see what it means. In my case, I don't want to do anything. I just want to copy the data. So now you see my task name is customer, and then the UI is configuring for me source with this name. So I don't like this name. I would like to get, because later we will be able to see those data sources or data sets. Customer, I have a typo, and I save. And then the destination too, I want to call it the same. So destination customer. Oops, again, customer. I already have destination customer. So let's call it customer 1. And I will show you how come we have it later. Okay. So, and because I had a typo here, it accepted mine. But if I do this customer, it will tell me that I already have one. And that's because when you delete a pipeline, the data sets are still there. So I'm going to just save them as that. Okay. And then I'm just going to do next. And it's going to prepare and run. Now, if I want to add additional stuff, I can edit the pipeline. If I wanted to, if I could just click finish, it just created the pipeline, but it did not run it. If I do monitor, then it's going to actually also run the pipeline. So as you can see, this is in progress. And if I want, I can refresh until it's done. And then I will start seeing the data. Once it's done, I can see the data in the customer folder of the data lake. So we're going to let it run. And I'm just going to show you what has been done. So if I go here, you see that I have the pipelines and the data sets. So the data sets, you remember that I was told that the data set customer already existed. It's because that was already created before. And as you can see, it does the same thing, AdventureWorks customer. Okay, so it was already there. If I look at mine, it's the same, the exact same thing, just a different name. So I don't like this. I would like to delete it. I delete the first one, and then the same thing for the destination customer. I don't want, as I will just show you. So the destination is the blob storage, raw customer, the same thing, and mine is the same thing. So I can actually delete this one. And now I will be able to rename and so forth. So these are the data sets. So basically what it means is that you can create data sets, and they are actually not, they're disconnected from the pipelines. Now you see here, publish. Every time I make a change, I have to publish it. Otherwise it will not take effect. So in this case, I deleted a data set, a source and a destination data sets. So I published, and now everything is going to be okay. Now I could go back and look at the pipelines, and I can see my new pipeline. So if I open it, I see, I go to copy. Now, again, I don't like this name, so I would like to rename it. So I will call it customer. And then my source and my sink, which is the destination, and the mapping. So I can do a lot of additional stuff here. I can create additional stuff. If I want to do transformations, I can continue once I copied the data, or I created a pipeline to copy the data, I can continue and do additional modifications to that pipeline. I renamed this, so now I have to publish it, and you can see, okay, I publish it, and now it's there. The pipeline is going to be updated. Let's review the, let's monitor. Okay, so now I want to know if my customer pipeline is already done. So let's do refresh. And it's still running because it's a big table. As you can see, my pipeline completed in almost 6 minutes. And this is because we have 8 million rows in that table. Let's go back. So what we've seen is that for now, I copied data from SQL Server to the data lake. Let's move on to the presentation to see what else can we do. Let's talk about Synapse. Synapse Analytics come with a workspace with 3 distributed engines. Each one has different capabilities. The one that we're going to talk about today is the serverless. Serverless does not need specific, when you create it, you do not need a specific computing power defined, and you're going to pay by the usage. And the beauty of this engine is that it points directly to the data lake storage without needing to upload data anywhere else. So once you have the data in the data lake, you can start analyzing the data immediately. This engine doesn't have the full capabilities of T-SQL and SQL, but it has a lot of power that you can use for your reporting and analytics environments. But we also have in the same workspace, we can create dedicated SQL pool, which is closer to the SQL Server agent in terms of T-SQL and SQL. And you can either point and analyze directly to the data lake with external tables or views or with Polybase, but you can also upload data into that dedicated SQL pool. It doesn't work because it's a distributed. The performance that you're going to get is much better than the relational database. And the last engine is the Spark pool, where you can Apache Spark, where you can do the same. Like you can analyze the data with Apache Spark and different languages such as R and Scala and so forth, and Python. So this is the architecture of Synapse. But today we're going to show how the serverless is powerful enough for a lot of the environments because you can analyze the data in the data lake storage directly using external tables or views. So what we're going to do and how we see the entire environment is that we already have the data lake storage with the folders and the files, the Parquet files on them. So what we are going to do is we're going to spin up, we're going to use the serverless SQL pool, and we're going to create external tables to point directly to the folders. Okay, so we're going to see how you can create external tables to point to a specific file or to a specific folder. And then we just query. So we connect to Synapse, maybe via SSMS or via your application. You run a query and then you get back the results like if it was a SQL Server agent or engine. But it's going to be much faster because the serverless is a distributed environment. So let's move on and see the demo. So we have the data lake. We're going to create external tables in Synapse serverless, and we're going to see how we query the data with Synapse serverless or from Synapse serverless. I'm back to my Azure dashboard, and here's Synapse. So I'm going to open Synapse that I already configured. In order to do things in Synapse, we have to open the Synapse Studio. So I'm opening the studio and I'm connecting. As you can see, we could also create pipelines in Synapse, but we already created our pipelines in ADF. Let's see what we're doing right now. So we go to data. As you can see, we have two things here, two tabs in data. We have our workspace, which is the SQL database, which is serverless. And if I open the database, you will see the one that I already created. I already created a database. And you will see external table that I already created. So you see I have external tables for the other tables. Let's see what we are going to do now. We're going to create external tables to point to our new customer table. So for that, I'm going to press on linked. And on linked, I had to link the Azure Data Lake storage. If you don't have it already, then you have to link a new one. So the way you would have done that is that you would do a plus, and then you connect to a data source, and you would have chosen the Azure Data Lake Generation 2, and you would have connected to the one, the same as we did before. But I already created one, so we do have the storage that I already created. And if we open it here, you will see that we see the silver and the raw. So if I open the raw, I will see my folders, and I can go, as you can see, also the test, which is empty, but I can see my customer. If I open this one, I will see further, I can see the file. So now I have two options. Either create an external table directly on this file, but what if I had additional files here? For example, if I would imported the customer table again, I would have two files here. So if I go to a specific file, I will only see that data. But I would like to see everything that is under the customer. So for that reason, what I do right click, new script, and I can either select the rows or I can create an external table. So if I select the rows, it will help me to, for example, create a view. But I would like to create an external table. So I will have the metadata of that table and not a view. So here you go. What it does, as you can see, the path is the customer with 2 stars. That means that every file that I will have under it is going to be included in my external table. And then I have to choose the max length, which is up to 4,000. And I continue. And then I have to select a database. In my case, I only have one AdventureWorks that I created, and an external table. So in my case, the name is going to be DBO customer. And I want to, what I want to do, I want to create the table using a SQL script. I want to see what it's doing. So let's open the script. So as you can see, it only going to create the type parquet if it doesn't exist already. But because this is not my first table, this is not important. So if not exists, it's going to create the type. And then it's going to create the external data source, which is for the Azure Data Lake. But again, it already exists, so we don't need that step. And then what it does, it looks at the files under this directory, and it generates the schema. So here you can actually modify the data if you need the data types. And as you can see, the location is the customer folder, all the files underneath it. And then it will do a select star. So now I have to choose a database where I would like to run this. If this is the first time that you're opening this, you will see that the run button is going to be disabled. That means that you have to choose a database where to run this. Okay. So now I can run this and it will create an external table. Now, if I would like to you see the publish all. If I would like to keep this script, I would just create external table customer. So anyone else can actually do the same thing, but I think this script already exists, so I will put a 1, and then I will just save. I don't need to save, I just need to publish. So this is the name of the script. I already ran it, and I'm just going to publish to keep the script. So I publish this, and then I can see my script. I will show you. So the script has been published. So if I go to develop, I can see all my scripts. So you see I have this one, which is customer, which is the old one. And then I have mine, which is customer one. So if I want to reopen it later, I can do that. I can just reopen it. Or I can rename it or clone it or do whatever I want with that script. Let's go back to my to the data, and let's look at the workspace, and let's open this. Let's just refresh. Let's refresh and look at my external tables, and I can see my customer table. So now what I can do is I can create a new script. Like I can right click and open a new script and select star from that table. So now I have to run it. I have to choose the database if it's not chosen and run. And as you can see, we have the data right away. From those script now, I can do whatever I want. I can do inner joins, and I can also create transact SQL. So inner join and so forth. I have those 4 tables, and I can see that. Let's make a test. I want to, so now just remember that the first time that you're running a query after a long time that you haven't in Synapse, the engine is getting warmed. So it may take longer the first time that you're doing that. Let's make a nice exercise. So I would like to do select count star from this external table. So imagine, so just remember this is querying the data from directly from the data lake. So how much time does it take? Not even a second. If I do the same thing in SQL Server, and I did it before, it took 23 seconds to do the select count. I can do it again once everything is already in the cache, but you will see that the Synapse is much, much, much faster. And now you can start playing with the inner joins and left joins and cross joins, and you will see that Synapse is much faster than the SQL engine. Sorry. So what have we seen so far? We moved the data, we copied the data over the data lake, we created an external table, and we queried the data with Synapse. Let's go back to the presentation now and see what else we have. We've talked a little bit about the queries and the performance. Let's see what else can we say about this architecture. So what can we say about the Azure Data Lake? You saw that we do not need to transform the data. We can just query immediately. You can, because it's very fast, you can also do some transformations on the fly, and it's going to be very fast because we're talking about a distributed engine that looks like SQL Server, but actually is much faster. It has a SQL Server-like interface in terms of SSMS and some basic functionality of SQL and T-SQL. It is the familiar T-SQL language. It's not the full capability. Like I said, you need to research and find out if the functionality that you need in T-SQL is good enough for you with the serverless. Otherwise, you may probably need also the SQL dedicated pool. But from my experience, most of the functionality for analytics and reporting is already there with Synapse and Data Lake. You can also use the familiar tools like SSMS and other tools that you're currently using with your SQL Server databases. It has a very good performance on the files, so you don't actually need to continue and copying the data further from the data lake. And it's not a relational database, so you don't have those issues that you have with relational database like locks, blocks, and deadlocks. Also, one very nice thing is that the security, it has the same security mechanism as SQL Server, so you can basically grant permissions to the external tables and views like you would have done in SQL Server. Also, it's well integrated with other Azure services such as the Purview and Azure Data Factory. So basically, when you're going that route, you have all the Azure services and functionality at your disposal. Let's talk a little bit about pricing. Basically, you can do the pricing calculation by yourself. This is the link. But let's see an example of how much it would cost you. So of course, if you're doing things, if you're moving data between on-prem to Azure, you will need an express route for better network bandwidth. In some implementation, you can only configure the VPN between on-prem and Azure, and it will work fine. You may also need Azure Active Directory, really depending on your security implementation. You will need, if you're copying data from on-prem to Azure, you may need to have a self-hosted integration services installed on-prem. And then the Azure Data Lake Blob Storage Generation 2, as you remember, we can have hot, cold, and archive layers. So even for 20 terabytes of hot layer with local redundancy and hierarchical model on a standard tier would cost you $512 per month US. The hierarchical model allows you to create folders under folders, and also if you're using partitioning, this is the way to configure your blob storage, the data lake blob storage. And let's talk about the Azure Synapse serverless pool. So like I said before, you're paying per compute power. So if we go to look at the pricing, this is the Azure serverless, you will see that you have either pre-purchase plans, or you can pay per usage. So this is, for example, for the data integration or in pipelines that you don't have to use that. You can use Azure Data Factory. So what's really interested us is the data warehouse component of the pricing, which is perform interactive batch streaming and predictive analytics with a rich T-SQL experience. And when we're talking about the serverless, we get 1 terabyte for free for the queries until the end of this year. And then after that 1 terabyte, the queries are being charged at a minimum of 10 megabytes per query, and the queries are being rounded to the next 1 megabyte. So it's also depending on your subscription type. So you need to look at the subscription type and the queries that you're running, to look at the sizes of the queries, and based on that, you need to analyze. But when you do that, you will see that serverless is much cheaper than all the other alternatives for analytics and reporting. So it's a very strong engine and not very expensive. Thank you very much, Data Platform Geeks and SQL Server Geeks, for giving me this opportunity to speak. And a very special thanks to Microsoft. So thank you very much, and please do not forget to enter your feedback and win prizes. Thank you.